Okay, so in this video, we're going to be talking about conformers and isomers, and then also practice some naming and determining if things are isomers or conformers or what exactly they are. So isomers are molecules that have the same molecular formula. But that means that there could be different types of isomers. So a conformer is a funky word, but also you can call it a conformational isomer. It's just kind of conformers, those two words shoved together. That means that the molecules have the same connectivity, but bonds are rotated to new orientations. For example, we saw this a couple practice slides ago in which we had butane that could be drawn this way with 4 carbons, or you can also draw butane like this. It's still 4 carbons, 1, 2, 3, 4, 1, 2, 3, 4, but that bond in the middle is now just rotated into a new orientation. So same compound, new look. So having the same compound but oriented in a different way is a conformer of each other. Pay attention to if the molecule is just flipped, the atoms are still in the same orientation to each other. So that would not be a conformer. So like if I were to draw that, these two are not conformers of each other. They are the same conformer. This also does not look like it says new. Let's switch that. New. Why isn't it working? There we go. Okay, and so the other kind of isomer that we're going to talk about are constitutional isomers. So these are molecules that have the same molecular formula, but have different connectivity. So you're manually moving things. Bonds are in new places. Same molecular formula, but different connectivity. So for example, we have our same first molecule here, butane, is different, not the same as this kind of butane molecule. So this is not butane anymore. That's not the name of it. It is a butane because it has 4 carbons, but it's not called the exact same thing. So these have the same C4H10. They have the same molecular formula, but they're connected to each other different. So they are constitutional isomers. So practice in this, we have 2 different practice slides. Our first slide asks us to draw all possible constitutional isomers for the molecules below. So the same molecular formula, but different connectivity. I'll do the first one with you, and then we'll do the other 2 on your own and check your work. So pentane is a molecule with 5 carbons. And it says here that we have 3 possible isomers. So I'm going to start by drawing my normal pentane molecule, just straight zigzag line. Then I'm going to take one of the carbons on the end and move it into the middle. One on the end, now it's in the middle. And then I'm going to do that again. One on the end, that was horribly drawn. I am so sorry. One on the end, move it to the middle. So those are our 3 conformers. That's kind of my strategy. I take one group and kind of chug it over at a time. Take a moment, try out the next ones on your own, see if you can figure out how many carbons they're supposed to have, and then all of the constitutional isomers. I am going to go ahead and just do a little transition here so that I have all of the answers on the screen because it takes a while to write them. So I will see you at that point. Okay, so now I have all of the answers on the screen for you guys. Hopefully you can check them now, see what you forgot, see what you missed. Okay, and then we're going to do another practice slide. says to identify if the following are conformational isomers, conformers, or neither. Explain why. So the first thing I like to do in terms of figuring out what these are is I like to number my carbons to see if there's the same number of carbons in each. So this first one, 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. So overall, I can tell immediately just by numbering that these are the same length chain and they're connected the same, but they're rotated into a new look, new orientation. Therefore, these are conformers. They have the same connectivity, just rotated. Okay, let's try the second one. So let's do the same thing. Let's number and see how many carbons we have. 1, 2, 3, 4, 5, 6. We have a seventh one up here. 1, 2, 3, 4, 5, 6, 7. So awesome. We have the same number of carbons in this molecule, so the same overall chemical formula it looks like. However, we can tell instantly, or at least we can tell after numbering as well, that in the second molecule we have 2 points that are branched off, whereas in our first molecule we only have 1. So we have different connectivity. That means that they're going to be conformational isomers of one another. So they have new connectivity. Or different, let's say different, that's a better word. Different connectivity, same molecular formula. Okay, and our last one, let's pick a new color. So let's count our carbons again. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6. So just based off of counting our carbons, we can already tell that we have a different number of carbons. So these are going to be neither, because they have a different molecular formula. Okay, those were some of our practice problems for identifying conformers and isomers and seeing if molecules are the same or not. So that is where we're going to end this video, and I'll pick it up with you guys talking about the next topic.